In the name of God, Engineering Mechanics, Statics, Chapter 3, Equilibrium, J. L. Merriam, L. G. Craig, 7th edition. In this chapter, at first we are going to discuss an introduction. Statics deal primarily with the description of the force condition necessary. Statics deal primarily with the description of the force conditions necessary and sufficient to maintain the equilibrium of engineering structure. This chapter on equilibrium therefore constitutes the most important part of statics, and the procedure developed here forms the basis for solving problems in both statics and dynamics. We will make continual use of concepts developed in Chapter 2 involving forces, moments, couples, and resultants. As we apply the principle of equilibrium. When a body is in equilibrium, the resultant of all forces acting on it is zero. Thus the resultant force R and the resultant couple M are both zero. And we have the equilibrium equation. As follows: R equals to 0 and M sigma M equals to 0. These requirements are both necessary and sufficient. Conditions for equilibrium. All physical bodies are three-dimensional, but we can treat many of them as two-dimensional when the force to which they are subjected acts in a single plane or can be projected onto a single plane. When this simplification is not possible, the problem must be treated as three-dimensional. We will follow our arrangement used in the previous chapter, chapter 2, and discuss in section A the equilibrium of bodies subject to two-dimensional force system, and in next section, section B, the equilibrium of bodies subjected to the three-dimensional force system. So the next section is the system in relation and free body diagram for two-dimensional problems.